Coders, welcome to the second part of problem number 1470, shuffle the array. I already solved this by using second array, but then I thought, can I do it without using the extra space? Till now I failed to do that completely, but I find an alternate solution which is at least less space than the previous one, because previous one was like trying to use the completely uh, same size of array, but this time I'm going to use a queue, which is another data structure, and you'll see mostly it will be really less than the another array kind of solution. So let's, as we already know about the problem statement, so I'm not going to go much detail on that. um, but yeah, in short, it is like we have x series and y series, and we need to create a pair of it, or shuffle, as the name suggests. So let's take a look at the diagram, like how I'm going to solve this problem. So here you have an example called nums of the original array. You have 251, 347, and then the output should be like 235417, which you can see from the example as well. Now, one thing to notice here is we are not going to modify the 2, which is the first element, and we are also not going to modify the last element, which is 7. So we need to just work on this part of the section. Now, the idea came from for the queue is, whenever we are modifying this array, the original array, we are actually going to uh, make changes on these two elements, or any two elements, on so forth, like first maybe 251, and then maybe this two section, and then so on, or depend upon the size of the array. So it means when we are going to override this area, we need to have some location, some section which is going to keep these danger, the element which are in danger. So for that only I'm going to use q. So for any operation or any iteration high level, we are going to store the endangered section into the queue, and then we can do all kind of operation the way we used to do, and then uh, we move on. So as I explained earlier, so we did not have to work on this and the last, so that's the reason why I'm starting from k equal to 1, which will be pointer pointing to the 5, and j equal to n, just like the previous example where we starting from the starting of the series of the y series. Basically y series is this, and is the x series. So how we are going to do that? So step 1, as I said, first move this 5 and 1 to the queue. So 5 will be at the first position, 1 will be the second position, right? Now what we are going to do is we are going to move k j equal to, like, whatever j is pointing to, j equal to 3, right? J will be moving to here, so now it has become 3, and we will be taking away from the queue, which is 5 over here. So reason being is we are basically modifying this and shifting it to here. So this is how queue is helping us. So we have already saved this to the queue, 5 and 1, so now 5 is coming here. So at the end of this iteration, we have incremented k two times, just like the last time, k plus plus and k plus plus. Now k is pointing to 3, so which is the indication that we have already covered all the elements that we are supposed to be queuing. So we no longer need to put anything in a queue. So what I'm meant to say is, only elements which will be in danger in now as well as future will be the this partition, the x partition. These elements will never be in danger, because all you're going to do is you're going to overwrite with here, right? And then again overwrite this to somewhere else. So regardless, whatever they have, even if you overwrite it after some time, we don't care, because these elements are already saved at certain location during the iteration. So only danger elements are part of the x series. Let's move on. So after the first iteration you have 3 and 5, and since we queued up like we did the polling, only one is left over here. So in the queue only one is left. Now k is pointing to 3 and j is pointing to 4. So same way, like first step is, since we no longer need to do any queuing operation, so we are not going to do queue up. All we need to do is start with the j equal to 4. So j equal to 4 will be moving to k equal to 3, and then in k plus plus. So now k is 4 and we'll be polling it from here. So now we already, and j equal to j plus 1, which is j equal to 5. So now as soon as we reached 5, which is less than, so we check the condition called j equal to 5 is less than 2n minus 1, which is 5. No, 5 is equal to 5, so we exit out from the loop. So let's take a look at the code in a brief. Yes, the code is here and it says I'm starting the queue with the queue. I'm declaring queue over here and starting the limit with 2n minus 1, which is, I don't want to write 2n minus 1 over here, that's why I put it, but if you can write 2n minus 1, it's not a problem. And then as you say, see, k less than n. So basically what I meant to say, as soon as the k is reaching to the midway, we'll stop doing any kind of queuing up operation. So as you see, like every time we are queuing up k and k plus 1 elements to save them from overwriting, right? And that's the regular operation, like nums k plus plus equal to series y we are putting, and again k plus plus equal to we are polling, and then finally we return the same nums. So anytime it is using less memory than the previous solution, um, and I hope if I can get it done without any queue, using just some few pointers, it will be, I'll be really glad. But yeah, till now I couldn't able to do that. So hopefully if I do that, I'll upload this another video. Thank you.